Let's finish worksheet 7. Okay, number 9, local linear approximation for f of x near x equals -3 is. Okay, so just to boil down the idea behind local linear approximation, all we're doing is we're finding the slope of the tangent line and then plugging in the decimal value. But here it's only asking for the equation of that tangent line. So we just have to find the derivative, evaluate the derivative at a point. Once we do that, we have our slope and find our ordered pair, and then write our tangent line equation. So first, what I did first was just to find the ordered pair. So plug -3 in for x, and I'm going to get square root of 9 plus 16, which is square root of 25, which is 5. So my ordered pair is -3, 5. Now I just have to evaluate the slope at this point. So to find the derivative, I'm going to have to go through chain rule. So I can rewrite this as x squared plus 16 to the 1/2. Okay, so we go through chain rule, bring down the 1/2, keep everything inside the parentheses, subtract 1 from the exponent, and then multiply by the inner function's derivative. So x squared becomes 2x, and then 16 is going to go to 0. Okay, rewrite this. 2's cancel out. X up top, denominator is square root of x squared plus 16. Okay, so now we want to evaluate the derivative at a point at -3. So plug -3 into the derivative function. So you get -3 over square root of 9 plus 16. So -3 over 5. So that's our slope. So my slope is -3/5. My point is -3, 5. Plug into point slope. Y minus 5 equals -3/5 x plus 3. And then we just have to match it up. This is in solving for y. So if I just add 5 to both sides, then that's going to match with answer C. Okay, number 10. At time t is greater than 0, the position of a particle moves along the x-axis given by x of t. For what value of t in the interval from 0 to 3 will the instantaneous velocity equal the average velocity of the particle from 0 to 3? So if you look at the wording here, this is referring to mean value theorem, right? So mean value theorem, we need to find the derivative, and then we also need to find the average slope. And we have our endpoints, so plug 0 and 3 into the original equation. So plug 0 in for t, and you're going to end up with 2. If I plug 3 into the original function, work that out, and that will get you to 17. So we have your ordered pair 3, 17, and 0, 2. We just find the slope between those two endpoints, and we're going to get 15 over 3, which is 5. Right. Our derivative, I can think of this as 1/3 t cubed plus 2t plus 2. Go through power rule for each. So 3t squared times 1/3. 3 will cancel out. 2t becomes 2. 2 is a constant. We'll go to 0. So then we have our derivative being t squared plus 2. Set the derivative equal to the average slope. Solve for t, and we get t is equal to √3 and -√3. Okay. However, time t is greater than or equal to 0, so we have to eliminate -√3. So only √3 will fall within our domain. Okay. Number 11. The figure shows f prime, which is the derivative function. And the graph f prime has a horizontal tangent at -3, -1, 1, and 4. Okay. Find all the values where our function is decreasing and justify our answer. What I like to do first is start with sine lines. Okay. So again, if you're looking at the derivative graph, you want to know what each portion represents. So anything that hits the x-axis represents where the slope is 0. Okay, remember you're looking at the f prime graph. Anything above the x-axis represents positive slope. Anything below the x-axis represents negative slope. So let's make our sine line for slope. Critical points, -3, 0, 2, and 4. -3, 0, and 2. Okay, with the endpoints being -4 and 5. All this portion is above the x-axis, so increasing, increasing, decreasing because it's below the x-axis, and then finally increasing. Okay, so we know the general shape of the graph just by looking at the arrows. Okay, we can also create a sine line for concavity and point of inflection. So all the max and mins of your f prime graph will be your point of inflection. So we're going to put those down as critical points: -3, -1, 1, and 4. Okay. The slope of your f prime graph represents concavity. So here the graph has negative slope. So this shows a decreasing rate of change for f prime graph indicates concave down. So concave down, positive slope represents concave up, negative slope represents concave down, concave up, and then finally concave down. Okay, so then based off the sine line, we should be able to answer the questions a lot easier. Find all the values for which f is decreasing. So decreasing, we see the graph is falling from 0 to 2. So justify your answer because f prime is negative. Find all values which function attains a relative max. So relative max will follow the arrows here. Increasing, increasing is going to fall and increase. So at 2, there's a relative max at x equals 0 because f prime changes from positive to negative. Okay. Part C, find all values of x which function is concave up. So we look at our sine line. We've already determined where the graph is concave up, concave down. So concave up in this first region, and concave up in -3 to 1, and then concave up from 1 to 4, because f double prime is positive. Okay. Particle moves along the y-axis, so that any time is given by t squared minus 4 natural log of t plus 1 minus 1. Find the velocity. So we have to go through the appropriate derivative rules. T squared is power rule, so it becomes 2t. Ln of u, the derivative ln of u is u prime over u, or 1 over u times u prime. So 4 times 1 over t plus 1, which is just 4 over t plus 1. And 1's a constant, will go to 0. So after I find a common denominator, I can make this 2t times t plus 1 minus 4 over t plus 1. Combine terms in the numerator, factor out the 2, and factor the remaining trinomial. So my critical points will be at -2, 1, and at -1. Okay, however, we're going to eliminate -1 because that's outside of our domain. So from our sine line, we can create from critical point at 1, and we can test the signs. So between 0 and 1, we're going to get a negative value. Greater than 1, plug into your derivative, you get a positive. So I'm jumping ahead a little bit. It's not necessary for part A, but for part B, it's saying find all the values in which the speed of the particle increases. So speed of the particle increasing, we have to compare lines between acceleration and velocity. So what I did here was I went ahead and I did the work for the sine line for velocity. Okay. We also need to do the sine line for acceleration. So we look at velocity. I'm going to rewrite this in the form so that I can find a derivative a little bit easier. I'm going to try and avoid quotient rule here. So I'm going to bring the t plus 1 up to the numerator. So I'm going to rewrite my velocity function as 2t minus 4t plus 1 to the -1. Okay, go through power rule for the first term. 2t becomes 2. For this, I can go through chain rule, bring down the -1, subtract 1 from the exponent, multiply by the inner function's derivative. So technically, I should multiply by 1, but that's not going to affect my my derivative. Okay, so then I can rewrite this as 2 plus 4 over t plus 1 squared. The only critical point I'm going to get is at -1, and that is going to be outside my interval. So it's just going to be from 0 being my endpoint, and so I can just test any point with the acceleration, and if I plug any positive value, I'm going to get a positive value, so I know my acceleration is always positive. Okay, so combining the two sine lines, I see that opposite signs from 0 to 1, so therefore decreasing speed. Same signs from 1 to infinity, so therefore increasing speed. Okay, find the total distance. To find total distance, we need to figure out whether this object changes direction, and it does at 1, okay, moves down and moves up. So we have to find the position at 1 and then find the distance between 1 and the endpoints. So I can plug all this in the calculator. 0 will give me -1, 1 will give me -2.77, 2 will give me -1.394. So then we just find the distance, okay, between each interval. So remember, when you find the distance between each interval, you should always get a positive value, okay. So in your calculators, you get 1.773. We subtract these values and we get 1.379. So then we add these two together. The total distance traveled from 0 to 2 will be 3.152.